Welcome to our presentation on Shor's algorithm. The problem with RSA relies on large numbers used in their encryption where modern computers don't have the computing power to run deciphering algorithms on these incredibly large generated numbers. But what if there was a computer that does have this desirable computing power? With the introduction of quantum computing, cryptography as a whole will change forever. In the future, when quantum computers are built, RSA is predicted to become void, where these quantum computers can easily run algorithms used to decipher the encryptions in a reasonable amount of time, no matter the size of the integer. So what kind of algorithm is used for deciphering RSA? Shor's algorithm is a prime example. When given any integer, it will compute and find the integer's prime factors. Shor's algorithm is a polynomial time quantum computer algorithm for integer factorization. It uses period finding, factoring from period finding, and then finally Shor's order finding algorithm to find the integer's prime factors.
The ethical problems are twofold. If you have access to RSA encrypted data, when do you use that ability and when do you not use that ability? Take, for example, the San Bernardino shooting of 2016. Apple had the ability to assist the FBI unlocking a shooter's phone, but they said no because they were worried that software would be widespread in the world after they wrote it. By unlocking the shooter's phone, they might have also prevented other acts of terrorism or given valuable information to the FBI. The stakeholders are everyone who uses the internet since RSA is so widespread. Data breaches are common even under what we would consider leading technology companies. With RSA encryption obsolete, even if you do everything right, your data will still be compromised.
So, what are the potential biases of Shor's algorithm? Well, Shor's algorithm is biased towards those who have access to a quantum computer. Countries like the USA and China have the resources available to both fund and develop quantum computers to the scale necessary for Shor's algorithm. Likewise, companies like IBM and Google have these same resources and can unilaterally decide who to make them available for and for what cost. Individual users, on the other hand, don't have access to commercial quantum computers outside of options to use quantum computers provided on the cloud by aforementioned companies. What is the ethical impact of Shor's algorithm? Well, governments can maliciously target nations that rely on RSA encryption for critical data. International companies hold influence over who is allowed to buy or use their quantum computers. And ultimately, individual users are at the mercy of governments and companies with access to these quantum computers. How can we mitigate these harmful effects? Currently, the only way to mitigate these effects is by replacing current RSA encryption with a new standard that is unaffected by Shor's algorithm and has no other pitfalls in security.